Alright guys, so check it out. If you're feeling a little bit of angst about this test, rest assured that it's just like the practice test. All these actual physical calculations that we're completing, we've actually done before. They're just in new and novel situations, such as the binomial distribution approximation. That is the section we covered before. I did some examples in that video. So I'm just going to go through this practice test and explain some things which might be a little odd. So let's just go through one at a time, okay? So if normal distribution has a mean of 20, a standard deviation of 10, then what? Well, remember what the curve looks like, right? It looks like, well, I might as well just show you what it looks like. You know, but I might as well just do it again. And, okay, so remember it looks like this. That's terrible. I'm doing it with like a cursor here. That's even worse. Anyway, you know, it's curved, and in the center is the highest frequency. And so the mean of 20 would also mean that the median would have to be 20 as well. Median is, of course, the middle. Normal distribution, symmetric, and unimodal. The mode is, of course, the most frequent, which would also be 20. So this is that choice there. Which of the following properties distinguishes a standard normal distribution from normal distributions? The standard normal is centered at 0 and has a standard deviation of 1, which makes it standard. That's like the z table, remember? When the data values are evenly distributed about the mean, the distribution is said to be symmetrical. Okay, even is same on both sides. So find the area under the standard normal distribution curve between these two values. So standard normal means mean of 0, standard deviation of 1. So I would go to my normal distribution calculator and just find these areas and subtract them. So, like, well, I guess I can actually do that if you want. Open up CAS. I'm sure you guys will like fast forward and stuff. Anyway, while that's booting up, I'm going to type in to the left of 2.05, then minus. Well, actually, I can just do CDF. So I can have my lower bound be here, my bound be there, and be done with it, and find the area. Come on. Okay, so calculator. Alright, so I'm going to do menu, statistics, distributions, normal CDF, upper bound we said was what? 2.05. Lower bound was negative 2.05. And these are my standard normal distribution numbers here, 0, 1. Didn't expect that to happen. Let's try that again. Sometimes this thing, my calculator is a little funky. It just won't work. Did I do it backwards? I did it backwards, didn't I? Negative 2.05. Upper bound is 2.05. Okay, is it 0.9596? Oh, there it is. Okay. Alright, find the z-score for which area to the right is 0.52. So this would be an inverse normal distribution calculation, right? Because you're looking for the area of 0.52. You want area to the right is 0.52, so we would have to find the complement of that, right? So 1 minus 0.52 is going to be 0.48. So I'm looking for the z value or the x value, if you want to think of it like that. That corresponds to an area of 0.48. And this is always going to be coming from the left, so that's why we had to find the complement. And it's standard normal, so it's 0, 1, right? So it's going to be z value, negative 0.05. Bottle of drinking water fills plastic bottles with a mean volume of 999 milliliters. Standard deviation of 7. Fill volumes are normally distributed. What's probability that's greater than 992? So that looks like a CDF problem. Okay. So normal CDF, I'm just going to copy that. Alright, my upper bound here was what? Oh, just basically some really big number. My lower bound was (992). Standard deviation, sorry, mean 999, standard deviation 7. Did I do it backwards again? Yeah. .84. Recent study found the life expectancy of people living in Africa is normally distributed with an average of 53, standard deviation 7.5. Person selected at random is probably that the person will die before the age of 65. So looks like standard normal distribution calculation again, like exactly the same. I guess I'll do it. Okay, so average 53, standard deviation 7.5. What's the probability? So if you're looking for probability, you're looking for area. Before 65, so my lower bound 0, upper bound is 65. Oh geez, 94.5%. In order to be accepted into a certain top university, applicants must score within the top 5% of the SAT exam. Okay, given the exam has a mean of 1,000, standard deviation of 200. What's the score? It corresponds. It's inverse normal. So we're looking for area to the right, which will be 0.05. It means to the left be 0.95, right? Standard deviation is 1,000. I'm sorry, means 1,000 rather. Standard deviation was 200, was it? Yeah. Oops, 2 decimal places. Whoops. So 1328 or 1329. Oh, I guess that's the closest one. Alright, I think my family's about to rage in here, so I'm gonna pause the video.